Hello everyone, let's consider this question together. Now we are given what? 36 to the power of x minus 6 to the power of x equals to 6. We are asked to look for the value of x. Now, do you know that 36 in index form is equals to what? 6 to the power of what? 2. So we are not wrong if we decide to write 36 as what? 6 to the power of what? 2 to represent what? 36. So this is what? Into 6 to the power of 2 to represent 36, or to the power of the power, which is what? X minus 6 to the power of what? X equals what? 6. Okay. Now at this point, we are going to remember one of the properties of what? Indices. We state that, okay, we state that into a to the power of m or to the power of what? N is equals to what? A to the power of what? M multiplied by what? N. This is one of the properties of what? Indices, which is will help us here a lot. Okay, it will help us here. Now, do you know that if a to the power of m is always to the power of this equals to this, it means that into a to the power of what? N or to the power of what? M is also equals to what? A to the power of what? M multiplied by what? N. Okay, this is one of the properties of what? Indices. So I'm not wrong, okay, and we are not also wrong if we decide to bring the exponent, the power here in, also bring this power here out by obeying these properties of indices. So we're going to have what? This is what? Into 6 to the power of what? X or to the power of what? 2. Because we know that 2 times s is equals to x times 2. Look at 2 times of s is equals to x times of what? 2. Because 2 times x is 2x, okay, and s times 2 is see what? 2x, okay, and minus what? Minus 6 to the power what? X equals to what? 6. Wow, it's amazing. So let me remove this one here quickly. All right, at this point we can see that something is common. Okay, we are having 6 to the power of x here, also having 6 to the power of x here. So we are not wrong if we decide to say let 6 to the power of x equals to any variable of our choice. Let it be equals to what? P. Okay, if 6 to the power of s is equals to p, okay, it implies that anywhere we see 6 to the power of s, we are comfortable to substitute what? P. So you want to add this is what? Into p, anywhere we see 6 to the power of x or to the power of 2 minus what? P, because you're having 6 to the power of s equals to what? 6, right? And the power of this p here is 1. 1 times of 2 will give us 2. So you're having p square, okay, minus p equals to what? 6. Now this is what? Quadratic what? Equation. Now from here, let's just go further and use what? Completing the square root. Since the constant term is at our right hand side, let's use what? Let's use what? Completing the square. Now what? This is what? S square minus what? P minus p, right? Now what we're going to do here is to add to both sides the half of the square of the equation of p. Add to both sides the half of the square of the equation of p. We know that the equation of p here is minus 1. So what is the half of minus 1? Half of minus 1 is minus 1 over 2. This is the half of minus 1. So we're going to add this to both sides and square it. We're going to add this is plus into minus 1 divided by 2 all square, okay, equals to 6 plus into minus 1 or what? Minus 1 over 2 or what? Square, right? Because we are doing what? We are solving it by completing the square, right? Now here we are having s, here you are having square, you are having square. You can open the parenthesis and take a single p. Then here I have what? Minus 1 over 2 or what? Square. It implies that if we open the parenthesis, we are going to have exactly what is here equals to what? 6 plus, this will give us what? This will give us into minus 1 square divided by what? 2 what? Square, by obeying the properties of what? Indices, right? All right, so what this is what? Into p minus 1 over 2 all to the power of 2 is equals to 6 plus minus 1 to the power of 2 is what? 1 divided by what? 4. Because 2 to the power of 2 is what? Is 4. So this is what? Into p minus 1 over what? 2 all to the power of 2 is equals to what? Now take note that the denominator, the 6 here is what? Is 1 here. Okay, so let's find the LCM between 1 and 4. The LCM is what? Is 4. Okay, so the LCM is what? 4. Now how many times with 1 going to 4? 1 will going to 4 times. That 4 you have times 6 is 24. So you have here is what? 24, right? Now this 4 times 1 you have times received was what? 1. So this is what? Plus 1. Okay. 24 plus 1 is 25. Okay. So that this is what? Into P minus 1 over 2 all to the power of what? 2 is equals to what? 25 divided by what? 4. Wow. This is pocket genius, right? Amazing. Now at this point, what are we going to do? At this point, we are going to remove this square from here. So for us to remove this square, we have to take square root of both sides, right? So the square root of what? Into P minus 1 over 2 all square, okay, is equals to the square root of what? 25 divided by what? 4. Now square root cancel out to square. Okay, we are left with what? P minus 1 over 2 is equals to. Now square have to do with plus and minus, right? So what is the square root of 25? This is the same thing as root 1 by obeying the rule of sort. 25 divided by what? Root 4, right? So that means P minus 1 over 2 is equals to what? Is equals to plus minus what? 5 divided by what? 2. Because root 25 is 5 and root 4 is what? Is 2. Now remember, we are looking for P. But in the initial question, we are asked to find X, okay? Why are we solving for P? We are solving for P so that this problem can easily be what? Solvable. Now from here, let's add 1 over 2 to both sides so that this can be removed. We are transferring 1 over 2 minus 1 over 2 to our right hand side. So we want to have what? We want to have that P is equals to plus minus what? 5 over 2 plus what? 1 over what? 2. So it implies that P is equals to what? Now plus minus 5 over 2 simply means what? Positive or negative, right? We want to have this is the positive what? 5 over 2, okay, plus what? Plus 1 divided by 2, or P is equals to the negative 5 over 2 plus what? 1 over what? 2. Now this is P1 and this is what? P2. Now from P1, we are going to see that P1 is equals to, since the denominator are the same, we are comfortable to add the numerator. So that this is what? 5 plus what? 1 all over what? 2. Take a single denominator. So from from P2, we are going to see that minus 5 plus 1 all divided by what? 2. The same, because the denominator are the same, right? So from P1, you're going to see that our P is equals to what? 6 divided by 2, which is equals to what? 3, right? Then from P2, let's see from P2, our P2 is what? Is minus 4 divided by what? 2, okay, because minus 5 plus 1 is minus 4, which is equals to what? Minus what? 2. Now we are getting that our P1 is 3 and our P2 is minus 2. So since we are getting the value of P, it's very okay for us to find the value of X. Now let's recall something very interesting from here. Now let me remove this from here quickly and recall something very important. Now we know from here, from our initial solving, that we say let 6 to the power of S equals to P. So let's see when our P is equals to what? When our P is equals to minus what? When our P is equals to 3. Okay, so I want to add that 6 to the power of X is equals to what? 3. Now how are we going to determine the value of S, because the bases are not the same, right? So what are we going to do? At this point, that means the logarithm will help us, or natural logarithm will also help us. Let's take logarithm of both sides, since logarithm is in base 10 of 6x log 6 to the power of S equals to what? Log 3. We are taking what? Log of both sides. Remember that log without a specific base, they are always in base 10. Okay. Now, if we obey one of the properties of logarithm, let me remove this from here. So I'll be stating those laws so you understand what I'm doing here. Okay. Now let me state one of the properties of what? Logarithm. Okay, let me state one of the law from here. The law states that if you have log m to the power of p base a, okay, is equals to, this law states that this will be equals to p multiplied by log m what? Base a. This is one of the properties of logarithm. It implies that this will become log s multiplied by log 6 equals to log what? Log 3. Okay. Now, since we are looking for x, let's divide both sides by log 6. Okay, we are looking for x, divide both sides by log 6. So this will cancel out this. We'll see that x is equals to log 3 divided by what? Log 6. This is the value of x. But we can also do something very interesting, right? You can also know our s as s equals to log 3 base 6. This is the value of x when p is equals to what? 3. Now let's see when p is equals to minus 2. Now when p is equals to what? Minus 2. We know that 6 to the power of s is equals to p, right? So it means that 6 to the power of s is equals to minus 2. Wow. But here we are having a negative sign. What are we going to do? By obeying one of the properties of equals identity, we know that e to the power what I pi by what equals identity plus what 1 is equals to what 0. So we can do something very interesting here. Though we know that the value of s will not be real because it will give us a complex what unit. But let's see what we can do. So if we subtract 1 from both sides, it means that e to the power what I pi is equals to minus 1 if you subtract 1 from both sides. So at this point, let's take log of both sides. So log 6 to the power of s is equals to log minus what 2. Okay. Now we know from this law that this now become what x log 6 is equals to. Let's see what you can do here. I can write this as what log into minus 1 multiplied by 2, right? Because I know that minus 1 times 2 is minus 2, right? Now I'm going to add this is what x log 6 is equals to log into. We know by equals identity that minus 1 is equals to e to the power of I pi. So that this is what 2 multiplied by e to the power what I pi. Okay, as you can see, because minus 1 times 2 is still minus 2. So if I divide here by log 6 base 10 and divide here by what log 6 base 10, this cancel out this. We see that s is equals to log what? Log. Let me just obey from here. That means 2 e to the power of I pi base what 6. You can see that this is a complex solution. So when s is equals to this is the real value to this problem. But when s is equals to this, it's a complex solution to this question. So thank you so much for watching. Please, if you find it very interesting, don't hesitate. You have to like, comment, and share video to your loved ones or others will learn from it. Please, if you're not subscribed, consider to subscribe to this channel so when another exciting videos you notify. So thank you so much and God bless you. Bye.